to Dr. Afif and Dr. Yazri. Okay. My name is Syamim Afif bin ZUHAIRI, and for my supervisor is Dr. Masura binti Muhammad Taha. For the bachelor degree project 2, okay, my title is Study on Effect of Fiber Modification toward Thermal Properties of Kenaf Fiber PLA Composite. Okay, for introduction, composite material is one of two different materials combined with properties and developed with matrix structure reinforcement. That form of material can be made with less energy consumption than all other fiber, and it can create minimal waste in this country. Okay. The third one, like other natural fiber, Kenaf is increasing appealing not only the composition industry but also to stakeholders. Yeah, for my problem statement is, there are too many filaments made from different types of plastic. Each of the filament has with their own properties such as the strength. And second one, there are no such thing of best composite filament that are suitable for 3D printing filament. For my objective is to study on effect fiber modification toward properties of Kenaf and PLA composite, and to investigate the chemical bonding and thermal behavior of natural fiber composite in 3D printed. Okay, for my scope study is to enlargement made in the structure of Kenaf fiber composite powder. Using DSC and TGA, it can discern thermal properties from the thermal degradation, gas transition, melting temperature and fusion heat. Okay, the third one, to identify the chemical bonding through Fourier transform infrared spectroscopy such as FTIR. Okay, the last one, to fabricate the filament for Kenaf with PLA composite through extrusion technology. Okay, for my literature review, Kenaf fiber. Okay, Kenaf fiber is increased appealing not only to the composition industry but also to stakeholders. Kenaf fiber attract a great deal of attention in the field of natural fiber composite because of their capability of polymer addition. Okay, Bongov say that Kenaf demonstrate low density abrasive during processing, high mechanical properties and biodegradable, and is present used in the food alternative paper and pulp industry, in the automotive industry, in the textile industry, and in fiberboard manufacturing. Okay, the processing parameter must therefore be developed with the best impact on the fiber life, aspect ratio, and chemical composition. This natural fiber have non-cellulose content which have caused poor polymer adhesive. Such special physical and chemical treatment is thus necessary to free natural fiber from unnecessary ingredients and to use the composite as a strengthening material, by Mandra and Bajpai 2020. Okay, for PLA, polylactic acid or PLA filament is another popular 3D printing material that is often compared against ABS. PLA has the ability to degrade into inoffensive lactic acid in the body, and due to the property, print temperature for PLA is 180 to 230 Celsius. Okay, this data represents the typical value that have been calculated from all products classified as generic PLA source. Okay. For methodology, okay, we can see for my process is we start with the detail fabricate the specimen. For my project, use 4 samples. Okay, 100% PLA, treated Kenaf fiber, Kenaf treat with 6% NaO and 1% silane with PLA composite, and the last one is Kenaf treat with 6% NaO and 2% silane PLA composite. Okay, for the study, I study about the thermal properties and chemical bonding. For thermal properties, I use for chemical bonding, I use a Fourier transform infrared spectroscopy FTIR, and for thermal analysis is I use differential scanning calorimetry (DSC) and thermogravimetric analysis (TGA). Okay, experiment method is firstly I sieve the Kenaf fiber using the sieve checker at FKM. The second one, alkali treatment 6% now for 2 sample fiber. This 2 sample Kenaf fiber soak for 24 hours. And after alkali treatment, the fiber will go into oven for 24 hours for moisture content, and after that the 2 sample will treat with 1 and 2% silane, and this fiber will soak for 3 hours. Okay, after soak for 3 hours, the fiber will put into the oven for moisture content test for 24 hours with temperature 110 Celsius. Okay, after that, when the fiber is done, okay, the chemical testing, we use the FKIR for 4 type of fiber, such as the fiber with code 6% NaO, second one 6% NaO with 1% silane treat of Kenaf fiber, the third one 6% NaO and second silane treat on Kenaf fiber, and the last one is untreated Kenaf fiber. Okay, after the test of the fiber, we use the filament extrusion for 4 samples, such as 100% PLA, Kenaf treat with 6% alkali and 1% silane treatment PLA, Kenaf treat with 6% alkali and 2% silane treatment with PLA, and untreated Kenaf with PLA. So we can see that the number 8 figure 8 show that the filament of our project. This filament extrusion we make at Unit KL mindset at Alogaja. Okay. After the filament extrude, I cut the filament just a small size like the picture number 9, and after that I used to check the differential scanning calorimetry with DSC. I use at KKTM, and the thermogravimetric analysis TGA for check the thermal analysis. This TGA I use at FTKMP. Okay, for result and discussion. Treatment of Kenaf fiber. Chemical treatment offer better physical and mechanical properties. Alkaline treatment is beneficial in reducing the moisture absorption and increase the interface bonding between sugar palm fiber and MATRIC. Okay. For the chemical analysis, what I get is water absorption was demonstrated at the peak of 1,700 cm. The peak with 2,900 compared to the CH station cellulose in the semicellulose vibration group of CH2, because hydrogen bound OH cellulose structure vibrate the wide ranging from 300 to 3,000, from 3,000 to 3,700. The standard life cellulose fiber of 1,200 to 1,500 with structure of lining and hemicellulose were revealed in the untreated Kenaf fiber. Another peak of 2,900 was normal CH with OH boundary was indicated by vibration. Okay. For vibration peak is 3,400. Okay. The low intensity peak from 1,200 to 1,500 was observed to treat Kenaf fiber with NaO and NaO silane, while the silane treat Kenaf fiber was approximately equal to the untreated Kenaf fiber. This chemical treatment has led to reducing both fiber water absorption. Okay, the low intensity peak from 1,200 to 1500 was observed for treated Kenaf fiber with NaO, and NaO silent, while the silent treated Kenaf fiber was approximately equivalent to the untreated Kenaf fiber. This chemical treatment has led to reducing both fiber water absorption. The chemical composition of Kenaf fiber has not been affected in large measure by NaO and silent treatment. Okay. For thermal analysis in the differential scanning calorimetry (DSC), in this DSC, okay, in the DSC analysis, the heat absorbed or released by a material is to be determined whether it is modified. The degrade DSC will control the fusion Tm temperature class, which is the melting temperature of the exothermic peak, where the endothermic submit is the crystallization temperature in this experiment study. The data show that the glass transition temperature of the fiber has increased between pure PLA filament 1% silent Kenaf fiber with PLA 2% silent Kenaf fiber with PLA, because the subtemperature movement to the value of the melting temperature by addition of the chemical treatment Kenaf fiber. Okay, the temperature of glass transition occur between 50 between 57 degrees Celsius and 60 degrees Celsius, but depending on the Kenaf fiber volume fraction. The greater the fraction of the Kenaf volume, the lower the endothermic peak. So for the glass transition of temperature for 100% PLA is 58.69, for 1% 59.32, 57.04, 58.06, for the melting point 100% PLA 151.23, 152.87, and 150.94. For the untreated Kenaf 149 degree. For the chemical bonding are broken or formed in the any chemical reaction, such molecules are natural keen to remain together. So chemical reaction between the molecule need less energy in comparison to break up of bonding between them that require more energy and result in thermal absorption. When chemical bonding are formed, heat is released, and when chemical bonds are broken, heat is absorbed. Okay, the value of 1% processing Kenaf fiber indicate the highest speed glass transfer temperature is another volume of Kenaf fiber from PLA filament to a subsequent height range of PLA filament. Okay. In relation to the temperature for the thermogravimetric analysis (TGA), in relation to the temperature due to the evaporation of the sample, weight loss rate specimen is regulated. In the plastic PLA composite fiber was treated with less water than the plastic PLA. Okay, this figure indicate the relation between 250 and 300 of the plastic PLA with untreated Kenaf fiber. Maizato says the plastic PLA and the Kenaf fiber produce higher temperature in the decomposition, such the ending of plastic have strengthened the bond between PLA filament simultaneous decomposition of the molecule from PLA matrix. Okay, for this graph DPG curve, okay, suggesting the Kenaf fiber treated with thiamethyl and glycerol has composed peak for the plastic PLA at around 300 to 430. The initial decomposition peak is caused by thermal hemicellulose repolymers, cellulose glycol interact, and acellulose breakup at a slower pace than other consumption, and constitute first integration by lining. The second peak look place at 450, which could also caused by a peak downgrading with glycerol of the PLA. Okay, for the conclusion. Okay, this study explored the effect of NaO, silent NaO, and on the morphology, structure, and tensile characteristics of the Kenaf fiber. Spectra show that Kenaf fiber treated with silent reduce its hydrophilic properties. Silent process fiber decrease their diameter because improvements are removed. The result of this study will assist the manufacture of silane Kenaf fiber of Kenaf composite. Furthermore, during the experiment test on the AC, the thermal properties of Kenaf fiber material has been found to absorb the release and or release heat while product is changing or deteriorating. The findings showed a value of 1% silane Kenaf fiber treat the maximum peak glass transformation of 59.32 degrees Celsius and the melting temperature is 152.87 degrees Celsius as compared to slightly higher the range to Kenaf fiber different treatment between pure PLA and untreated Kenaf fiber. Okay, the thermogravimetry analysis show that both samples of plastic PLA composite have improved their stability due to fiber treatment and that further delay in PLA matrix degradation and the essential stabilization action of the composite has been observed. Okay, the final result show that 1% silane Kenaf fiber treatment with PLA has been developed in the study. In study as permanent biocomposite material for use filament fabrication. This because compared to other treatment and untreated fiber, the glass temperature of 1% silane treat was higher. In addition, the amount 1% treat Kenaf fiber was shown to be accurate for the high shear rate and high viscosity of Kenaf pseudo-plastic fluid properties and composite were similar. Okay, that's all for me. Thank you.